Now, H prime, I'm going to say that it's going to be a high pass filter. Okay, it's going to be like this. High pass filter, this is H prime. Right? High pass filter, 0 in DC, and passing high frequency is 5 minus 5. Right, that's high pass filter. Okay? What happened to that spectrum after we've gone through this high pass filter? What happened here? We'll preserve the spectrum. Right? So we have 5 and 2. 5 and 2 is exactly 0 because it's 0 here. Alright? And we preserve spectrum. This will be like that. So here, depending on what filter do I use, I can have a low pass interpolation or a high pass interpolation. The filters still have to be a half band filter. Right? So here, let's say H of n is 1/2 minus 1/2. Right? That's the example we have. Okay, and so on. How do I find a half band high pass filter? Let's say this is 0, 2, and minus 2, and let's say this is minus a quarter, and minus 3, and 3. How do we know how to find, how does a half band low pass filter look like? How does a half band high pass filter look like? What are properties of half band filters? What happened at time 0? No, half band filter is 1. 2, 0. And minus 2, 0. And minus 1, so on, minus 4, and so on, right? So the only freedom that we have is something that comes 1, plus or minus 1, plus or minus 3, and so on. So what should it be? Negative. So what's the value of time 1? Minus 1/2. Time minus 1, minus 1/2. And time 3. Minus a quarter. 1/4. 1/4. So how do I write x prime of n in terms of x of n? Understand? Minus 1 to the n. Good? X of? Very good. So you see that the high pass filters, right, retain the same sign for even index. Right? The n equal to 0. Minus 1 to the n is 1. N equal to 2. N equal to 2 is 1, and so on. For even index sample, they have the same value. That's what we want, right? Have 0, 2, minus 2, and so on. Those are the half band conditions that we have to preserve. For odd index, what do we have? Odd index, I want to be negative. So, but how do I know that if this is the frequency response of H, this is the frequency response of H prime? How do I show it? What does H prime e to the j omega equal to? Who can test?
That's E is omega minus
J omega minus
B.
I. That's correct? You're going to show that. How do I see that? How do you know that?
We see uniform frequency of S omega by T.
But how do I know this is pi? From here to here it's clear. But how do we go from here to here? How do we know this is the modulation by pi?
Using Euler.
Well, so what's another way to write this? Very good. So that's the modulation. Okay? By pi. So if you write it this form, it's obvious using the Fourier transform properties. Modulation by pi, you shift by pi. So an ideal low pass filter, shift by pi, and an ideal high pass filter. So later on today, in math lab exercise, you have a chance to do all of this. You see, spectral, you see the image. What happens when you calculate this? Okay? I'm going to take a 2-minute break. So you can actually stand up and stretch. 2 hours, too much. To sit. So just stretch for a few minutes, okay? I will erase this, is that okay? And then we will be discussing the other operation now by M. Is that okay? Yes. So how do I invert the system? This is X, this is Y, now sampling. So tell me the operation that we have to do here. This operation, insert L minus 1 sample, 0 sample. What does the inverse system have to be? Remove L minus 1, 0 sample, right? Sample. Okay? And that is what we'll discuss next. Okay? That is downsampling. Or another way to say this is y of n is retain meaning you save, okay? Retain even in next sample. Take an example, right? Suppose X is, let's say, take the other one, right? So it's 1, let's say 2 at 1, 1 at 2, minus 1 at 3. What is Y equal to? How do I draw Y? I'm saving, keeping all the even index sample. I'm keeping the 0 index, I'm keeping the second index, the fourth, and so on and so forth. Okay, so at time 0 is 1. At time 1, it will be 1. That's it for this example. Okay? So, what is the shorthand notation for this? Two way. Okay? So y of 0 is x of 0. Y of 1 is x of 2, and so on. Okay? It is linear? Yes. If you add 2 samples, you retain even the next sample. So the next sample will add. Right? So linear, you come invariant.